So I think we're gonna start with a small group discussion first about the video itself. I was trying to get some of the questions you have from the posts, and so there are a few things that might be interesting just to consider as you are going to talk with your neighbors about the video itself. So one thing is, I guess some of you, actually many of you, were asking about how to choose those priors. Okay, so prior choices in the video. Maybe you have some ideas, maybe you have further questions. So feel free to discuss that. I guess especially with the gamma and the beta prior, some of you were just curious about how those got chosen, so gamma and beta, and some of you found that the normal was overall making sense. So I think that would be something good to talk to your neighbor about this. And another one is, I think Julie asked the question, how to incorporate the individual and the group level, and what he means by that. And I'm trying to, I guess, connect that to Josh's question, how individual level inferences can be extended to group level inferences. So I would say, maybe as you are talking with your neighbor, the individual level, as well as the group level inferences, and how to make the connections. Okay. And I think Josh also asked about like the coding. So in fact, I should just double check with Professor Yo again, but when I got this a couple of years ago, I think I had this JAX script, pretty complicated, pretty long in terms of writing the model. So I'm pretty sure he did it in JAX, but I will double check if he has any kind of updated stuff. And I will also upload the JAX code on Moodle if any of you would be interested in checking it out. So that will be my quick answer to that. And I think another general questions people have, a couple of you were asking, I guess, why he multiplies the two power functions together. I think some of you offer some insights in your responses, but as of now, I would just like post it as a question, multiplying the two power functions, I guess, when he develops the more detailed model. Okay, so the two power functions. And yeah, your thoughts about it will be nice to discuss with your neighbors. And Shanshak, who's from Amherst, he asked about like whether it will make sense to use a mixture model to be a little bit less aggressive. Okay, so I just posed the question here as well. If you want, you can log in Moodle just to check out those questions or like comments in general. But I give you the time to talk with your neighbors for a few minutes about your thoughts. I mean, you can post even more questions. I don't think we'll be able to answer all of them like as of now, but all of those are important to keep in mind as we go through the lecture for this unit. So hopefully by the end, we'll get a better idea of how those, especially like individual level and group level, how to make those inferences connect to each other. Okay? Let's spend a few minutes talking with your neighbors, and then try to maybe address some of the questions here from you, and then we're gonna start the lecture that I prepared. I think maybe talk about number 2, because for the other ones, especially the 1 and 4, I would just bring up the slides that Professor Leo has, so we can have a more focused looking at that. But before we move on from this set of questions, anybody wants to talk about number 2, how to combine or connect or incorporate individual level and group level inferences in the particular study that was introduced?
Sorry, I don't have an answer, but my question was, once individuals are classified into learners and not learners, like I wasn't sure how that information can be helpful for inferring in a group level. Is it like you calculate the proportion of learners in that group and that helps? Or I wasn't really sure.
Anybody got the question? So that was why I guess was at the second model that we're doing the individual classification, and each person is being classified as learner or not learner, right? So I guess Josh's question is, how does that connect to, I would say, yeah, how was it done from the individual level to the group level when you're trying to make group for, I guess, group level inference about learner or not. Is that anybody like commenting on that, or just like commenting on your understanding of the video so far, and reading comments about other comments about comments?
My understanding was that for the people who weren't classified as learners, there was just that first power function to describe their data, and then you only looked at the second power function for the learners, and that was just based on the pattern of their responses.
Right. So maybe let me ask first, what is the group, or what are the groups in the study in the first place, based on understanding?
Isn't just the average of all the people, like the response time?
What do you think? Maybe people have different ideas.
9 groups, so one letter NIW, so letter plus the different contextual language combinations, so
Yeah.
3 times 3.
Yeah, let me actually just bring the slides now, so that would be easier to talk about in a second. So yeah, so I think it's probably important to identify what are the groups first, and so if we do, let's see. Right, so I guess there are 3 by 3 because first of all, there are 3 types of words, right? The known words, the novel words, and the scrambled. And so that's why you see, and then there are like 3 different letters, NIW. So that's why you have 9 different, 3 by 3, 9 different groups that you're working with. So is it true that within each group, they're doing classification of individuals to be learners or not? Or it's more overall?
I think it was within each group. I mean, like when you would look at the graphs, like all of the graphs, they would have 9 different ones total.
Right, yeah, so let's see. I think this was the 9 different graphs, right? Like 9 different, I guess this was in
Yeah, it was in the first model.
Right, so yeah, I mean, this was like one of this graph, and or one of the dot plots that we saw, and I think for each of them, they're designing this power function and then putting priors, all that. Yeah, and then in the end, they put everything together in this way, and then they're trying to put the same prior distribution for, say, the muti, let's see, for the sigma, for the alpha and beta, or yeah, alpha and beta in the, and gamma in the power function itself. So I think it is true. I think we might be wrong. I don't know, but I think it is within each group, 9 groups in total. Within each group, we're looking at classification of learners or not. Okay. So then we come to this point. Let me just show you.
I thought in the first, when it was like those new kind of ones that we were just looking at that site, that was when they were looking at like the aggregates of the entire
Right, that's the
population.
aggregate.
Wasn't that before they were classifying people as learners versus non-learners, and then they started classifying?
Right, yeah.
Oh, okay.
Right, yeah. So I should mention, yeah. So there are 2 parts here. The first one is looking at the aggregated data, right? Like there's no individual level, but then so in this case, so one thing important to take away is, regardless of whether you're looking at individuals specifically or just groups specifically, you will have hierarchical model in both of them. Okay, so hierarchical model, it does not have to be like, say you realize like you have individual level data, then you have hierarchical. It's more about like if you have multiple groups, in this case, even at the aggregated level, when you have multiple groups, you're able to do a hierarchical model because you want to borrow information across the groups. Okay, so in the first model, we saw that it's aggregated data for 9 different groups, but even just among the 9 groups, you're able to do some hierarchical model. Okay? But then the second part of the video goes into, I think the transition is here, that the red curve is the aggregated data, right? But then for each, like it's aggregated among, I don't know how many individuals in that group, but you can see that the pattern looks very different. It's aggregated compared to the individual. And then if you look at this a little bit more, you can see the different shapes or different trends of how those learning is taking place. So then we come to this point. So maybe I'll just show all of them together here. And I'll just ask one of the other questions on the board earlier that, do you think it makes sense to have the product of two power functions together in the setup as it is right now? Some of you are not too sure, but since now we have this on the screen, anybody wants to comment on like what does it mean? Like what are the differences between the two curves? Two curves, right? Like the blue one or greenish one and the red one. And then for the red one in particular, the second stage of this, this whole process, I would say, this whole area here seems to be a multiplication of the two power functions, right? So yeah, before anyone volunteers, just maybe quickly check with your neighbor for like a minute or so, just to talk through that. Do you think it makes sense to have this multiplication of two power functions? And what does it imply in terms of the model? All right, anybody have a comment about like the multiplication here? Does it make sense? And maybe, I mean, some of the additional comments about like how these functions are working. Anything is welcome. Anybody?
It's just like a guess, but to me, like some people saying, actually, it didn't seem to make that much sense to have this curve defined by this product, because really, like, what you would think actually is that like that variable omega, as I recall, is like that also has like a probabilistic distribution, and like that represents the point at which like that drop off occurs. Like across individuals, and so it would make more sense to have like a piecewise function defined on the interval like 1 through omega and then omega through n, suppose, and like for before the drop off, like have one function model like that process, and then the other process after omega be a different function rather than the product of it. I don't know, but
so the drop, so regardless of what the function itself, but I guess it's important to get a drop here simply because, well, the y-axis is what is the response time, right? So if you're not classified as a learner, that's the greenish or the bluish curve, or like the cases there. So the response time doesn't really decrease as the person learns more or tries more. But the orange ones here, it will, like, based on the data itself, you see a clear drop after a while. And then that was the point, I think. The model is trying to classify people as learners or not. And then it's maybe multiplication, maybe something else, maybe a piecewise function, all that. But I think it's trying to capture this trend in a sense that once somebody becomes a learner, then the person will need much less response time to the tests, right? So yeah, that's my take at the moment. We probably can dig this into a little bit more. Anybody else?
I think that these two curves could be for the same individual, they're just for the different letters. So because N is the start of the word NIW, you never know when that word's going to start, so you never get faster at predicting that an N is coming. But if you learn that NIW is a word,
Right.
then if you've seen N and I, once you've seen that word a lot, you know that W is coming next, so you get faster.
Yeah, good point. Yeah, so I actually don't know the answer to it, and we might address this question to Professor DeLeo once we get the chance. But I guess Caroline's point is pretty valid here, because this might just be one person's response time. But then, because again, the letters are classified, I mean, there are 3 different letters and then the triple. So for N, so that's why I think they have this subscript, right? And then W over here. So they're trying to put them into different letters, like labeled by different letters. So we'll see a different trend over here. Okay. So yeah, so let's all like keep in mind all of the questions and concerns that we have. And once we cover the hierarchical modeling itself, maybe all of, like, some of this will become clear. So we're gonna come back to this after, I guess, a couple of lectures. So, okay, so that's for the discussion. And what we gonna do